Okay. I'm not seeing myself currently, but is everything visible and okay?
Yep.
Yep.
Okay.
Seems good. Do you maybe want to discuss one or two of the questions that came up in the break, in particular the one about where to find more information about the world builder and where people could
Yes.
find documentation?
I was planning to do it later on, but let's do that now. So let's just go to the virtual box. So what you can do is the first point to go to is to go to this website. Let's see, a little bigger. So that's the Geodynamic worldbuilder.github.io. And that link is actually posted in the chat by Lorraine. So if you go there, you can get to this website. It will have a little bit of an explanation, an example file. I guess I should also put a nice picture in there. But more important, the most important buttons are up here. So one of them is that you can go to GitHub, you can have installation instructions, you can go to the manual and the developer documentation, and you can download the zip. So if you go to documentation, so let's open it in a new tab. This is the same developer documentation, the same type of developer documentation which is available from Aspect. So if you search here for example, spherical, you can click on this, you can get some information of how these classes work. But it's mostly for developers. So if you want to use the world builder, you probably want to go to the manual. So if you click on there, it will open a PDF. Let's make it full screen. And you get to see this. This is the manual for the world builder. And so the world builder has the manual has different sections. It has a short introduction, which I already explained over here. It tells you how to cite the world builder, some acknowledgements, and then it has installation instructions for all kinds of different situations. And if your case is not there, please let me know. Then we can figure out what the installation instructions for your particular case are, and we can add them to the manual. Then there is a section on using the world builder. And this will have more in-depth detail of the different components, but it's also set up as a tutorial. So it will go through a very minimum example, which we went through today. And then it actually starts out with different coordinate systems, 2D and 3D. We'll actually look at 2D later today. And then it will actually start with the continental plate, explain how it works, how to set it up. And then it will go through the different features which are available and explain how they work and what their options are. It also explains some, what are some cookbooks over here, but it will also explain some more of the advanced features, which I probably won't have time to talk about, but you actually don't need Aspect to make a peer review file. The world builder has an internal application which you can build, which can create peer review files for you. It also has an application which allows you to just query individual points and get a temperature back. So that's useful if you just want to make your own ASCII file, for example. You can use that to create your own ASCII file initial conditions from a world builder file. And then, well, it has a little bit of information for developers. And then there's a whole section on, well, basically an appendix, which contains all the different parameters there are, what their options are. So, for example, version over here, it's a string and it has some information about what it is. And yes, so there are all kinds of different. So this is the surface temperature, the temperature almost at surface in Kelvin, and you can actually force it to make sure that it's always surface temperature is being forced at 0. Here are some adiabatic etc. So there's a lot of information you can find in this manual. Then there's GitHub. And so the world builder is not part, the code is actually in Aspect, but it has its own repository where it's being developed. And so you can find that at github.com/geodynamic worldbuilder/worldbuilder. So if you have questions, you can just go to issues and you can make a new issue. I would have to log in here. You can make a new issue and you can ask your question. And feel free to ask your questions in this way. So I think that covers most of that question of where to find more information. There was another question on the power view, which I also can show you quickly over here. So as you can see there, we have this box with different compositions. And so the only thing I did here is to make sure that you can see all these different compositions in there is actually have a solution. I created threshold, so that's that little T in the box over here. So if I click on that, and for example, I want to create a threshold on composition 1. What I do is I set the minimum higher than 0, so it will ignore everything else than composition 1. And if I do that, it will create a box for everything in composition 1. What I then did is instead of coloring it by composition, because that's not useful anymore because it's all composition 1, I set it to a solid color, and with this slider over here, I go to solid color and click on it, and now it will show up gray. If you want to give it a different color, then you go up here to edit color map. So that's the second button from the left. If you click on it, it will show you a box where you can choose colors. So in this case, I want to choose a green. So I click on the green. I will click OK. And then it will show up as green. Okay, notice it. Okay, so there's a question about going from 0 to 60 in the bottom of the box. So Aspect both has a notion of depth and the X direction. So, or in this case, the Z direction in 3D. And the Z direction is exactly the same as an aspect. So you don't have to worry about that compatibility. It's just that the world builder uses depth preferentially to define things inside of the world builder file. So the world builder thinks of depth related to a reference surface. Well, an aspect, you usually define it just with everything with respect to a 0, 0 point. So it's a different way of thinking about it, but you don't have to worry about that conversion. That's being taken care of. Okay, so let's switch back to the presentation, unless there are any pressing questions. Okay, so just to recap what we did before the break, a small recap is that we added a second oceanic plate, and we have given it a linear temperature with a maximum depth, and we have given it two different compositions, one in the top 50 kilometers and one in the bottom 50 kilometers. And that's what you see over here, the top 50 kilometers and bottom 50 kilometers. For the rest, it has a linear temperature profile, and you can see that actually. So this plate model, in infinite, it will go to a linear temperature profile, but you can see that there's a small difference currently still between a linear temperature profile and the oceanic plates temperature profile. So if I would probably make it 1,000 kilometers longer, it would be exactly the same. But now you can actually nicely see the difference between the two plates. And the other thing I did before the break was just to add a mental layer. I did that by making a new object. So remember, an object starts with the curly brace and ends with the curly bracelet. So this starts with this curly bracelet and ends with this curly bracelet. And I gave it a model name. So this is the plugin in Aspect language, which is called mental layer. The name is, I gave it a name, which can be can be anything, but make it descriptive. So I made it an upper mantle, and I gave it a minimum depth and a maximum depth. And I gave it coordinates. I also gave it a separate composition. And so if you did this exercise, I hope you managed. There are actually two ways of doing this. What you could do is you could make another composition, another feature object mental layer, and you could give it a lower mantle, and you could give it a minimum depth of 660 kilometers and a maximum depth of, I don't know, whatever you want. Then just give it a different composition number. The second way you could do it is you could actually just add make the maximum depth larger and add a second compositional model over here, just like we did with this oceanic plate. And then you have two different layers. So there are multiple ways of doing it. But then you would need, you would need to change the name to something more appropriate. Just meant would. Okay. So now we only need to finish our model by adding a subducting plate. And subducting plates are, again, they are an object. So they start with curly brace and end with the curly brace. And they also, subducting plates are a plugin. So you set the model subducting plate, and subducting plate requires two different things. And they're laid out over here. They require coordinates. And remember, this is now a line feature. So the coordinates basically define the trench of the subducting zone, of the subduction zone. So that's why where you point the coordinates to. You need to provide a dip point, and this is this point defines the direction in which the subducting plate is dipping. And I will show you that in a minute how that works. And then you have segments, and segments are the downward part of the plate. And I'll also show you how that works in a minute. So this box is red because it's only a part of this file. This file will just work fine, but I only show a part of the file, and you see the dots over here is the part which is missing. And so I gave the model name subducting plate. I gave it a name. I just called slab for now. You can name it whatever you want. And I gave 3 coordinates. Remember, in this initial box we had 3 different coordinates which define the slab. So we're going to give those coordinates over here. Then we give the dip point, and the dip point is just the direction in which, or defines the direction in which the slab is going to dip. And then we can define segments. And for now, we just keep it at 1 segment. And each segment, so a segment is a list, and defined by these angle brackets. And and a list contains different objects, defined by these curly brackets. And each segment object contains at least a length a thickness, and an angle. It can contain more, which I'll show you later, but that's the minimum. And this defines a volume. So we have a line, we have an angle, and we have a thickness and a length and an angle. So with all these things, and we know in which direction it's dipping. So with all these things, we define a volume. And then, like before, we can just fill that volume with temperature and composition, which is exactly what we're going to do. So we're going to define a temperature model. And this, we're going to keep it simple for now. We're going to use the uniform. And we're going to give it a uniform temperature of 293 degrees Kelvin. And secondly, we're going to give it a compositional model of uniform composition, and we're going to set it to composition is 2. There's a question, where did I define the dip direction? So the dip direction is being defined by this dip point, and I will show you what the dip point is in a minute. But the definition of the dip point is the direction in which the plate is dipping. So we have a line over here. The basic idea is that we have a line over here, and we need to define on which side of, I'm not sure if you can see my video, but on which side of the line it's dipping towards. And so that's why we have this dip point, and where that dip point is defining where it's going. So in this case, just to continue with the dip point was 0, 0. And we can see in this box that our origin is over here. So the 0, 0 is over here. It's this point. So we hit the line over here. This is a trench line. So that means it's going to be dipping in the direction of this point, which is in this direction. If I would have defined the dip point over here, it would have dipped in a different direction, in the opposite direction. But it does not really matter whether I would have defined the point here or here, because it's all on the same side of the line over here. So the dip point, which is this, it just needs to be on the right side of the line, and then you're dipping in the right direction. There's a question, can the well builder define create a flat slab solution? Yes, and I will show you how to. I can show you how to do that later on, and you can probably in a few slides you can probably figure out that yourself already. And in this case, I'm not going to run this, but if you want, you can run this just with RFM7 basic sculpting plate of PRM. That's the parameter file, which will create this directory with the per view file solution in it. And you can just visualize it with the same procedure, just loading the state. For now, I just want to point out that in the composition, we see that it has actually a different composition, and it's a uniform composition. And you might be noticing that we were here missing a part of the model. And that's because we actually set the temperature to be 20 degrees Celsius, so that's 293 degrees Kelvin. And our threshold for the temperature is 300 degrees Kelvin. So it's lower than our threshold, so peer review has cut this out. But we'll make it more interesting in a moment. And there are two things we're going to do to make it more interesting. So this is just the same file we had before, and there are two things we're going to change. So one thing you may notice is that both the thickness and the angle have curly braces around them. And if you may remember, sorry, not curly, but angle brackets around it. And if you may remember, these angle brackets actually mean that you can add multiple values in here. And in this case, you can add up to 2 values in here. And these values define, in this case, for example, in this case, what the thickness is at the beginning of this segment. And so in this case, for the whole slab, because it's just one segment. So what's the beginning, what the thickness is at the beginning of the slab, and what is the end of this slab/segment. And for the angle, it's the same. The first value will define what's the angle of the slab at the beginning, and second will define what's the angle at the end. And it will linearly interpolate between the two. And I'll show you what it looks like in a minute. The other thing we're going to do is we're going to add just a more interesting compositional model, which is for the slabs, which is also called a plane model. And that's based on the McKenzie 1970 paper. If someone is interested, I can actually add the reference to the paper in the chat at some point. But I forgot to add it in the slides. But it's basically just a linear temperature, and then you start heating it up from both sides. And that will create a reasonably accurate representation of the temperature of a slab. There are other ways of doing it, which are better in some cases, but we'll keep it for this for now. So there are two things we're going to do. Just to repeat, we're going to add a second angle. So actually another angle here. We want to start at 0 degrees and we go to 60 degrees. So we want to have a nice curved slab. That's what we want to start out with. And we want to have a more interesting temperature. So just for your reference, you see a difference over here. We add just a 0 comma before it. And here we change it from uniform to plane model. And it actually requires a density, and it requires a plate velocity. There are more parameters, but this is the minimum you will need. And this one we're actually going to run, but just for your reference, this is what it will look like. We have this slab over here, which is curved. From 0 degrees over here to 60 degrees over here. And you can see a little bit at the beginning of an interesting temperature profile. So new share. So I suggest you already start running it. Where is it? There it is. So let's close this. Let's go back to okay. So this model, so I'm going to run it with 4 cores. So use your own aspect release. The resolution again is a little bit higher. And we're going to use RFM8 curved temperature sorting slab plates.prm. Oh, wait, correctly. So we're going to run that. Let's see if no other questions. And so for me, it's done. If it's not done, it should be done, well, I guess within a minute if you have only 2 cores. And what we're going to do is, again, the same as we did before. We're going to open ParaView. And we're going to load a state over here. So file, load state. We're going to select mixed again. So PV view mixed C1T. We're going to click OK. So use the mixed one, just the same one as the previous one. And we're going to, again, like before, search under file specified directory. And we're going to select the 8 one. So RFM reference model 8 curved selecting plate. So RFM 8 curved selecting plate. This one. And click OK. Click OK. And that will load it up. So I can actually take a close look at it. meanwhile, there's a question: can you define temperature conditions and matter properties inside aspect when you use the well builder? Is there conflict? So I guess this question has to do with the fact that I specified the density. And the reason for that is that the Mackenzie model requires a density. But it will actually not provide aspect with densities, because densities are computed in aspect itself. And they're mostly specified by the composition. So this would be up to you to make sure that density you set in aspect for the composition is consistent with the density you give for this particular model. And so let's take a closer look. Again, it's a little bit hidden. Let's see if we can make a cross section over here. So what I'm going to do is I'm going to select the temperature one, and I'm going to set it to clip. So that's the third one from the left. And then I want to change some of the properties of this clip. First of all, I want to have it in a different direction. So I set it to -1. And I set to -1 instead of 1 because I remember that that's the correct one, at least I hope. And then I'm gonna set the origin of the plane to, well, let's say 2000. Apparently it was actually 1, so I misremembered it. My fault. And now we can actually see a little bit of the slab already. You can see it has a nice curve, and you can see it has a temperature profile. But let's say we want to have a longer slab and a more interesting slab. So let's now go back to slides. And so what we are going to do is we're going to add a second segment. And a segment, so these slabs they go into the depth, and the segments define different parts downwards. So I had a slab which is 200 kilometers, which had a thickness of 100 kilometers and an angle from 0 to 60. But now I want to define a second segment, and that second segment will be added to the first segment. We'll see that in a moment. In this case, I want to give it a length of 500 kilometers. I want to still have a thickness of 100 kilometers, but now let's make it even more interesting. Let's go from 60 degree angle to a 20 degree angle. So this is the only change we made. We added an extra line. We gave it a length, a thickness, and an angle. And this is actually what is in the aspect release. In the RFM 9 segments within plate of PRM, which we're not going to run for now. You can run it on your own, and you can view it in exactly the same way as before. But that will show you something like this, or it will actually should show you this. Or at least I might have, I see is no difference between my picture and what I see in power view, but that has to do with the direction. But yeah, let's just keep it for now. So what you can actually see is that we have, this is our initial part, and we now just added 500 kilometers of slab in the second segment, and we went from 60 degrees to 20 degrees. And what is important, at least unless you want something really weird, is that you keep these two angles the same so that they match. Also, if you're going to change the thickness, you also might want to keep them the same when they overlap. Unless, again, you want to do something really interesting. And what you can see now is you can see a little bit more of the temperature. Yes, this is just a plate model, which shows it's heating up when it's going down. That's how that temperature model is defined. And it's not actually heating up, it's just an initial condition, which we show here. It's an analytical model of how it heats up. Okay, so the last part before we're going to break, and actually before we have our reference model, is that we're going to make it even more interesting. You saw in the reference model, I may not have pointed out too clearly, but the compositions are actually a little bit more complicated, and there's one part, and I can actually just show you that this is what a reference model looks like. We have one part of the slab which actually has the same blue material, but it doesn't have it all the way down. So this segment has a different compositional model than this segment. And the way to do that is, so this is again, the previous film we had, I created a little bit of space over here. And what you can, so we defined length, thickness, and angle. And what we're going to define as an extra is in composition. But you can do the same, you can also add a temperature model if you want. But for now, we're just going to add a composition model. And the only thing we're going to do here is we're going to add two compositional models. And one is for the top part. It's a uniform model. It has a composition of 3. And with these slabs, we measure the distance from the slab top, because we need some kind of reference. So it's not a normal depth, but it's the distance from the slab top. So that's why this has a different name than you used to. But the principle is the same. The minimum is always 0 and the maximum is always infinite. So the max, we're going to set the max distance slab top to 50 kilometers, and we're going to set it for the other one with a different composition. We're going to set the minimum to 50 kilometers. So this creates two different compositions in the first segment. So remember, this is within the first segment. It will override basically the compositional model. And so you can run it with this command. Although when you do that, if you haven't given your virtuals, you've seen a lot of, I made it very high res. If you haven't given your model a lot of RAM, then it will probably crash. But if you run it with enough RAM, it will generate this very high resolution model. And just before the break, I will show you how to set it to a lower resolution to run. But your question might be, well, we have a reference model, are we done? Well, not quite yet. So we have a break in a minute, but there are two more things I want to cover today. And those two things are how to make 2D models and how to make slab with differences along strike. So along the trench, your slab might be getting shorter in one direction than in the other direction. So how do you deal with that situation? Things I unfortunately can't cover today in time given are topics like how to use spherical geometries. It's actually not that hard. You just set the type to spherical and you change all the coordinates to spherical to degrees instead of Cartesian coordinates, and then you should be fine. But I don't have time to show that. Other things I can't show you today is how to deal with different artifacts in initial conditions, in interpolation of coordinates, some global versus local parameters. We already saw a few examples of those, but and how to read error messages. If you have questions about either any of those, you can ask them during the discussion section. I'll be happy to explain it to you. But for today in the presentation, I won't have time to cover it. And you can see the manual for more information on the topics, and you can ask during the session. So before we take a break and go into 2D models, I just want to quickly show you how to actually change the input file of aspects to make it more manageable on your system. So what you would need to do is leave paths, and so this is the reference model you would run .prm, and in your case it will say 4 over here, but if you change this to 3, you should be able to still have a nice high resolution, but manageable by your system. If you gave it a lot of RAM, then please go ahead and use 4, but it might take a while because it's going to be a big model. So I would say if you want to run this, change it to 3 or even 2. Otherwise, let's take a break. And if there are any questions, let me know. Are there any questions I need to answer now before the break? Is it possible to find?
We had 2 quick questions about functionality that we may also discuss in the discussion section because they are relatively specific. But if you have a quick answer, then feel free. The first one is it possible to make holes in the slab?
Quick answer is yes. I can show you.
We can discuss the details
in details
later.
In the discussion section.
And the second one is it possible to have 2 slabs instead of 1? One in front of the other.
Yes. I can interpret that question multiple ways, but I think either way it's yes. I mean, you can define several slabs in your model. That's not a problem. If that's the question.
Okay. Yeah, we can probably discuss that in the discussion section when we can also ask what specifically was meant.
And I will show you also a little bit more advanced slabs after the break.
Okay. And then I think Lorraine has an announcement before we go into the break.
Thanks.
Yeah, I would appreciate, I mean, this is the first time we've done this all virtual tutorial for both for Aspect and World Builder. And we would appreciate your feedback on how this went for you and the content and the speed and the length of the tutorial. So I posted in the chat the link. If you can spend a few minutes during the break doing that, that would be really, really appreciative, especially for those of you who've made it to day 5, your feedback would be very important. We will, of course, sending this out to all the participants, and the survey will be open through the end of this week. But while you're fresh, if you could spend a few moments, that would be awesome. Thanks.
Thank you. Menno, how long will we make this break? 15 minutes? You're muted at the moment.
Yeah, I think 15 minutes should be fine. If we need a little bit more time to have a break, and that we can make it 20 minutes, I guess.
That's true. Yeah.
Yeah, I think if people need to fill out the survey at the same time.
Yes. So let's make it 20 minutes.
20 minutes. So that would be 15 past the hour or 45 past the hour.
Yes.